then you substitute this 1 and 2 into this equation, and you get something like negative 8 over 5. How to get the second derivative? To get the second derivative, you have to differentiate this one. Again, remembering that y is the function of x, and y prime is actually a function of x. So you can substitute this y prime into this equation and differentiate it. You can try to differentiate this one, which is also going to be correct. But differentiating this one is probably the easiest, because again you're going to have just one line differentiation. And when you get to y prime, you simply substitute this this number instead of y prime. So let's try to have it written. This is basically 2x plus 3y plus 3xy prime plus y prime equals to 0. Again, we differentiate with respect to x. 2x just 2 plus 3y, this is 3y prime, because y is a function of x, differentiating with respect to x equals y prime, plus, this is the complex function. This is going to be 3y double prime plus 3x double prime plus 3y prime plus this one is both of these are functions of x. So this one is going to be y prime times y prime plus y times y double prime. Is it clear why I just solved if we differentiate this one? Any questions about this one? Y times y prime is actually f of x times f prime of x. And now when we differentiate this one with respect to x, what we get? We get first f prime of x times the same f prime of x which we had, plus this one is the same, f times f double prime of x. Which is why we get this expression over here. And this one is equal to 0 because we differentiate 0 with respect to x, we get 0. So in this expression we have x's, y prime, and y double prime. This one, this term is actually y prime squared. Y prime times y prime is y double prime squared. Y prime squared. So we know that y prime is equal to negative 5, 8. So we can substitute this negative 5, 8 into this expression. We can substitute x and y into this expression because x and y is equal 1 and 2. And as a result, we have to collect the terms and get to something like 126 over 125. I guess it shouldn't be a big problem how to collect the terms. I'm just trying to explain the principle here. So we have chain rule, we have implicit functions, and we have logarithmic differentiation. differentiation is very good when you have a function which is the product of several functions. So for example, if the function is, for example, some function of x to the power of alpha times some function of b to the power of beta, and you have to get the derivative of this, you can go straight ahead and get very long expression. You can basically take the logs on both sides. And then take the derivatives of those logs. So what you have to remember is what is the expression for the derivative of the log of y with respect to x. If you remember this one, then many problems are going to be much easier for you. What actually makes economics a little bit difficult to study sometimes is that sometimes we have quite simple problems from the mathematical point of view, but it's, one has to see this mathematical problem behind the economic problem itself. So for example, we have some economic application. And this is just a model of the closed economy. So in the closed, when we see some economic models, we usually don't see any numbers at all. We just see some just pure functions. So here we have y, which is the national income, and this is the sum consumption plus investment. This is very simple Keynesian model, very basic ones, and we know that consumption is some function of y, some function of income. So this is consumption, and this is investment. The question is how to find the change in the income which is derived from the change in consumption, dy over di. Change in investment, yes. How the income changes if investment changes. Which is again, as a problem, it is quite easy. Because right now, what we have to write down, we have to substitute this function of y into this formula. So what we get y is the function of y plus I. And now we have to differentiate both parts with respect to y to I. So we have dy over di is going to be f prime of y times dy over di plus 1. And this one is probably the more difficult to understand by yourself. This is exactly because y is the function of y is a function of I, but c is the function of y. So we have the complex function here again. But since but once we wrote this down, it is very easy to collect the terms. So we basically have this one and this one. And as a result, we have dy over di as 1 over 1 minus f prime. 1. To this list, we have to add one more thing, which is the Taylor's rule.